Okay, section 15 of the notes. This is the part where we're going to just talk about what we've done, what you need to do. It's the principle of mathematical induction, typically is a PMI. Once you complete this, including the homework in this section, you're to do the web assignment, Math 120, topic 15. All right. Also try to do something in a weekly discussion group if you can. So we went through this, we went through the method. Hopefully that made sense to you, and you've studied the notes. Not only studying the notes, but making sense out of what's been presented to you during lectures at the whiteboard or at the blackboard, depending where you are. I noticed some formulas over here. I think we proved some of those in the lectures. Certainly this one's a very important one, is some of the integers from 1 to n. Some of the integers being squared from 1 to n squared. Some of the integers being cubed from 1 cubed up to n cubed. Fourth power, fifth power. It gets tough. I want to point out when you get to calculus, you certainly should throw the first two. All right. Now, by the way, I throw the third one on there as well, the cubes. It does pop up. All right. Now, these kind of over here, we're more interested in you be able to prove these guys over here than to remember them. Okay. So it says, at this point, you don't need to memorize this stuff. When you get Calc 1, you should try to memorize this, at least some of that stuff that we presented to you. PMI is an important proof technique. We talked about PMI through this. We did some examples for you. We proved some stuff, and then eventually we get to the point after going through those proofs saying, it's time for you guys to study and for you guys to start to try the material. But this stuff's all been presented to you, right, at the blackboard or on the whiteboard. And so we're going to do supplement activities now. What does that mean? You need to supplement your educations by studying. My technique when I was in school was to basically read books, and certainly books are a great way to learn, and they really are. I think it's the single greatest way that we learn is by reading. And I'm not just saying mathematics, but a lot of things, and just in general human experience by reading. It's something unique to humans. So we want you to try, though, after you go through that, you're making sense out of the world that we present to you, which is PMI at this stage, that you start doing these things. I'm going to go to the whiteboard, and when I do that, I'm not going to copy the notes for you. I mean, the notes are in front of me. They should be in front of you as well. I'm going to do these, and I'll certainly do number 1, and I'll do number 2, and I'll do number 3. I notice with number 2, though, they say that, bottom line, there's a footnote over here, and it pays to read. It really does. Would say here you may want to use your calculator's ability to do symbolic algebra. And this is so typical. When things get really tough with the algebra, we need a computer algebra system. I'll go over that, and we'll go over this code over here with respect to the problems in the notes. But right now I'm going to switch to the whiteboard. I'm going to do number 1, and you should be able to do this on your own as well. Hopefully you've done this already, and you're just not watching me. You're actually doing it on your own. So I'm going to go to the whiteboard, and give me a second. And I got to open up a whiteboard for you, right? Okay, so I'm going to, and again, we're in section, I got to remind myself what section we're in. We're in section 15 of the notes. All right, so section 15. Section 15. And we're doing the homework. Again, homework is something you do outside the classroom, and hopefully you are comfortable with the material that's being presented to you. What's number 1? It says use PMI. I'll certainly write it down for you. This is going to be the sum I equals 1 to the n. N is assumed to be an integer, I squared, equals 1 squared plus 2 squared plus 3 squared plus yada, 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 up to n squared. They claim that's equal to n plus 1, 2n plus 1 over 6. Well, first thing I would write down is P1. All right, now what's P1? P1 is a sum, 1 squared up to 1 squared. I'll put what I'm doing over here. N is 1. 1 squared. It stops there. I'm going to put this down and see if it's true. I don't know if it's true. If it's not true, I'm done. All right, sorry about that. I had a little mark on the screen. So 1 times, well, 1 plus 1 is 2, and then 2 plus 1 is 3 over 6. And certainly, I guess 1 squared does equal 1, right? So this is 1, and 1 squared is 1. Again, 2 times 3 times 1 is 6. 6 times 6. That looks like good. Worked out well. Now what do we do? We write down pk. Write this over here. Okay, I'm not going to use sum notation. I'll just write this. What is it going to be? 1 squared plus 2 squared. I want to point out, again, for the students not following this over here, this is Pn. This whole thing over here. All right, and keep going. 1 squared plus 2 squared plus 3 squared. Now I'm not using it. I'm using k now, right? So it's going to stop at k squared. You know what? I'm going to get an eraser out and make sure you understand that this, although I have k over here, I got to get a better looking k for you. All right, I'm going to erase that. Okay, that's my letter K. Okay, equals K plus 1, 2K plus 1 over 6. Now, what I'm going to do now is I'm going to try to show that this leads towards PK plus 1. Oops, I did that K again, didn't I? I mix up K sometimes. Let me write that again for you. K, whoops, I did it. Wow, I really am screwing up here. What's that going to be? 1 squared plus 2 squared plus 3 squared plus yada, yada, yada. Then it's going to be k squared, but I'm not stopping there. I'm stopping at k plus 1 squared. Oops. I'm going to go to the other side. Well, it's going to be k plus 1. Wherever I see n, I'm putting k plus 1, by the way. This would be k plus 2. All right, and then what do you get? Well, 2 times k plus 1 is 2k plus 2. So it's going to be 2k plus 2 plus 1, which is 2k plus 3, all over 6. All right, here comes the part that a lot of students really struggle with. What we're going to do is we're going to show that pk eventually leads to pk plus 1 by simple operations. And one thing I'm going to do is I'm going to add the same thing to both sides. And what I'm going to add to both sides? I'm going to add to both sides k plus 1 squared. I'm adding this to both sides. So if I add to the left side of the equation, I add it to the right side of the equation. Now, what do I immediately notice? The left side, which is 1 squared plus 2 squared plus 3 squared plus yada, 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 up to k squared. I just added k plus 1 squared to that. All right. What do you get on the right side? K plus 1, 2k plus 1 over 6 plus k plus 1 squared. Now, I'm looking at this and I'm saying, you know, this obviously is identical to this over here. It's obvious. All right, that's obvious as day. Problem I have over here is I wonder, does this really lead to this? I don't know. So I'm going to push on the side. And this is where to start. Let's look at this and say, I don't think I can do that. I think you can. And I'm going to start working through it. And the first thing I'm going to do is I'm going to get a common denominator, which would be 6. I'll write this down for you. K plus 1, 2k plus 1 plus 6k plus 1 squared. All right. I'm still looking at it. I wonder if it's true. It doesn't look right to me. So what I'm going to do, I'm going to keep moving forward. I'll put this over here now. I'm going to factor it. I move this a little bit over here now. Whoops. And I'm going to say what factors out is k plus 1. And what he left off with? K plus, I'm sorry, I made a mistake there. Get my eraser out again. I factored out k plus 1, so that came out. Left with 2k plus 1 plus 6. And I factor out one factor of k plus 1, so I get k plus 1 over 6. It still doesn't look like it matches that guy. In other words, let me point out what I mean by that. I'm looking at this, I'm looking at this, and I still don't see it. All right, so I'm going to keep going. And I got to work on it. Maybe one more step here. Who knows? Maybe it doesn't go there. It would be awful though, wouldn't it? This would be k plus 1. That would be 2k squared plus, I'm simplifying now, 2k squared plus k plus 6k is 7k, right? Plus 6 over 6. I still don't see it. I'll keep going. K plus 1. Let's see. If it's going to work, it's got to be 2k and k, right? I'm trying to factor that quadratic there. And I'm going to say, it looks like, let's see. I'm going to say 2 and 3, maybe. I don't know if it works. Let's see if it works. 2k times k is 2k squared. That worked nice. Then you get 4k and 7k. That worked nice. Now you get 6. Now what I'm going to do is I'm going to look at it. All right. And someone says, what are you looking at? I'm looking at this, and I'm looking at this, and I'm wondering if they're the same thing. Well, I'm seeing this. I'm seeing this. I'm seeing this. I'm seeing this. Maybe in different order, by the way. And I'm seeing this, and I'm seeing this. And of course, 6 on the bottom, both cases. So the response is Q. Let me get the black ink. Q, E, D. All right. All right. So I'm going to go to the next question. Next question is, we certainly don't explore these in a classroom. It's been improved. So that format can be used now. I'm going to go back to a different share. And I'm going to go back to a share where we're going to start talking about, and just give me 1 second here. All right. So again, we just did number 1. We proved it by the principle of mathematical induction. Certainly, if that was being typed up, I want to point out, I did that in a scratchy work for you on the board, at the whiteboard. If work is being typed up, though, it would look sort of like this over here, and it should be nice and neat. It really should. You should try to aim for that. Okay, so I'm going to do number 2. Now, certainly number 2, this is footnote 93. It says here you may want to use your calculator's ability, and I'll tell you the number 1 reason why is that these things here, 4th degree polynomials like n plus 1 to the 4th power is going to take a lot of work. All right, but what I want to do is I want to go to Sage. All right, and I want to use this as my computer algebra system, but you're free to use your calculators. And I noticed that there's n as a variable, but before I do anything, I'm going to reset. I think you probably remember doing this before. N equals a variable. And I'm going to say n is my variable. And I want to go look at my code over here because I'm new at Sage, right? So I guess I did this, I did that. Here's something I'm probably, maybe I should talk about. And it says assume n is an integer. And I want to point out this is what we're doing with these problems. We're saying that n is an integer. All right. So see, I guess it did that, right? Let me type this in over here. I wonder what this is. Right. So I'm going to go back in the notes. I'm looking at this, by the way. N squared, n plus 1 squared. I think we just did this, didn't we? Let's put this one down. I'll go back in the notes and show it to you, though. And, I'm just going to type that in, right? So n squared. You see that? I get a little tired. I'm going to copy. I go back in my notes. And I want to point out what I just typed in over here. I typed this thing in here. So let's see. Maybe I didn't type that in. What did I type in? Ooh, I typed in number 3. So n squared, n plus 1 squared, 2n squared, plus 2n minus 1 over 12. And then what I do is I added n plus 1 to the 5th power to it. Now, I hope you realize what I'm doing over here. I'm taking this thing here, and I'm adding to both sides of that equation n plus 1 to the 5th power. Let's go back over here. And I'm going to put this down now. Okay. So someone said, what'd you just do over there? I took that entire expression that we just typed in and I factored it. All right. Now, certainly it should remind you. Let me tell you what we mean by reminding you. We just did problem number one at the whiteboard. What do? We took this expression here, we added n plus 1 squared to it, and then we kind of factored it. All right. Well, what are you going to do now? Well, I'm reading through this. That's all I'm doing. We want you to read through it as well. It says over here now, they're doing something by defining a function now. Let me put that down for you. an is being assigned. What's it being assigned? Well, I guess it's being assigned this thing over here. All right, let me write an down for you. All right, I want to go back in the notes. And I want to point out what we just typed in. We're calling this an now, this thing over here. N squared, they were a little differently. N plus 1 squared, 2n squared. I'm just making sure I typed it in right. And it's 1/12 of that. Good. All right, let's go back over here. I want to point out a lot of times in mathematics, proofs are so difficult that machines are used to help humans do the proof. All right. So I'm going to type this in. I'll tell you what it stands for. BOOL is a Boolean function, and it's going to return either it's true or it's false. And what I want to see is A of n plus 1? That's the next thing up. Remember, we're trying to do pk gives you pk plus 1. Is it the same thing as n plus 1 to the 5th power plus an? This is the big problem we have with the other problem. Remember that? All that work with the factoring and stuff. Well, it's either going to say yes, it's true, or no, it's not true. It's true. All right. So I want to point out what we did over here with all that code. All right. This was tough. What do we do with the code? We just proved this with the code. What do we show? We put an down. This was an. It's the sum of the integers, being raised to the 5th power up to, from 1 to up to n. We said it's equal to this thing over here. I just did PMI, right? On a computer, right? I want to see if I can do this one. That looks tough, right? So I'm not going to clear the screen, by the way. I'm just going to define an now. An is n star. I'm just copying this. Whoops. N plus 1 star 2 star n plus 1 star 3 star n. You're going to make mistakes typing, by the way. Plus 3 star n minus 1 divide by 30. All right, let me see if I typed it in right. n plus 1, 2n plus 1, 3n squared, 3n minus 1 over 30. What do I want to see if it's true? I want to see if this is true. I want to see if an plus the very next term on, which would be n plus 1 to the 4th power, is identical to n plus 1. Let's hope I didn't make a mistake. It's true. This is also a true formula. Let me repeat this. This would be really, really tough for me to do by hand. It could be done, though. I'm not saying it can't be done. It's just a tremendous amount of work. It's important you start to realize, even in upper level mathematics, you're going to have to be able to learn how to use a machine to do an awful lot of work. However, if you can't do the basic stuff that we've talked about, the simple problems, a machine is not going to be of any assistance to you for these more difficult problems. You need to pay your dues with doing those small problems first. All right, that covers that. I think we're done with that. And that's about it. All right, so good luck. And that's a short section. I know in class we spent a lot of time in that. PMI is important. Good luck.